Okay, number 10 is also one that's going to require us to use our formula sheet. So on this one, it was a little more specific. It already told us that it's a right tail t-test, and we're trying to find our critical value. So critical value for a right tail t-test, we're using inverse t, our alpha value, and our degrees of freedom. So here's our alpha value. N is 40, so our degrees of freedom is going to be 39. So we're going to do inverse t 0.1039. Okay, now one of the things that you need to be careful with on this one, the answer on your calculator is going to come up negative, but since it is a right tail test, that means your answer has to be positive. So we're going to put our T critical as positive 1.30. Okay, number 11. Obesity is defined as a BMI of 3 kilograms per meter squared or more. It has been shown that 21% of U.S. adults age 20 and older are obese. A researcher believes that the percentage has gone up and wishes to test the claim. They have a sample of 100 and they calculated a 95% confidence interval. And here is our confidence interval. So what we're looking for is they have run this test, H sub O, the original percent was 21, and the alternative, they are saying now that it's greater than 21. So we would run this test. We don't have enough information to run the test. All we have is this confidence interval. So what we're looking for at the end of our test, we always run a confidence interval to confirm our result. And what we're looking for is whether or not the original hypothesis is in this confidence interval. And it is not in the confidence interval. So what that means is we are allowed to reject the null hypothesis. Okay, a principal at a school believes that his students are above average intelligence. A random sample of 30, so that's my sample size, have a mean IQ of 112, so that's my X bar. Given that the population standard deviation is 15, so that's sigma, test the claim that they have a mean IQ score greater than 100, so this is mu. So the null hypothesis is that the mean IQ score is 100. He thinks that his population of students have an IQ that is greater than that, so we want to make our alternative greater. Alpha is going to be 0.05. Now for this one, we're dealing with means, so we can go ahead and throw this out. And because we have sigma, that means we're going to run a z-test, okay? So for this one, it wants you to find the critical value and test statistic and use that to make a decision. Now, when you run the test in the calculator, it will tell you the test statistic. It will not tell you the critical value. So for your critical value, you're going to have to use your formula sheet. Because it was greater, it's a right tail test. So the first thing I'm going to do is inverse norm my alpha value, 0 and 1. Okay, so I get 1.645. So this is my Z critical. Okay, so anything to the right, since it's a right tail test, anything to the right is considered my reject region. So now what we want to do is we want to find the test statistic. Now you could run this in the calculator. I'm going to go ahead and just do the formula though. So the formula for the test statistic, I'm going to do X bar minus mu. So my X bar was 112 minus mu was 100 over sigma divided by square root of n. So I'm going to compute this. Show you how I'm typing it in. So I got 4.38. Now, if you want, we can run the test also just to confirm. So it's a z-test. Null is 100, sigma's 15, x bar is 112, n was 30, and we think it's greater. So that verifies we get the same value. So we get a test statistic of 4.38, and that 4.38 is going to be clear out here, which is clearly in our reject region. So we will then say reject the null.